We shall start general science module today. Okay. Let me first introduce you the subject, that what is the importance of the subject for UPSC examination and what you can expect from us, that is Vision Eyes. If you see, general science is often confused with science and technology. I don't know that whether science and technology module is going on or it has been over, but please do not take both things the same. They are really different, because UPSC has defined general science under prelims. Okay. So as per UPSC, general science questions will be reflected in prelims examination. Science and tech is clearly mentioned for mains under paper 3. Okay. UPSC has rather defined the subject. At least they have written nanotechnology, okay, information and communication, space, everything is written over here. But if you see general science, nothing concrete is mentioned. Okay, they have just written general science. You have to use your head, that's what you are going to study. UPSC has not at all defined. At Vision IS, we cover general science under two different modules. One is your physics plus chemistry module, and other is biology module. This module will be covered by another faculty. I am not concerned for that. Okay. I will be covering physics plus chemistry module. Okay. Science and technology can be taken by any of the faculties. So now see, science and technology is of mains, I told you, right? But if you observe the trend of UPSC, every year they are asking questions in prelims as well. So this portion also holds a lot of water as far as prelims is concerned. So you are expected to finish your science and technology before prelims. Do not consider that UPSC is not going to ask any question from this. Now let's analyze the trend of UPSC. If I have to say, then physics and chemistry is the least important among all, I would say the most neglected one. Okay. So from physics and chemistry, you can expect around 1 to 3 questions as per the trend. 1 means this is the trend, 3 means if you are lucky. From biology, you can expect around 3 to 5 questions. And nowadays, 5 to 7 questions are from science and technology. So just see the trap of UPSC. UPSC is saying that in prelims you will ask from general science, but UPSC is entering in the domain of science and technology. Now science and technology is having more weightage than general science in prelims examination. So please do not neglect that. Now what is general science and what we can expect? As the name clearly reflects, it is general. General means you need not understand the technicalities of the term, okay, but you should be aware of the terms in layman terms. If you have understood the things in your own way, that is also going to help. Going for the formula, going for the derivation, numerical aspects, not required. Clearly it is writing general. General means you should understand the concept and the application of concept.
जो आपने बाद में लिखा है सर इसी को रिपीट कर देना।
Very sorry. There is some technical glitch. So I was saying that general science is divided into physics and chemistry and biology module. Okay, you can expect around 1 to 3 questions and 3 to 5 questions from here. And the term general signifies that you are not expected to go for numericals or derivations. It is only about understanding the concept and their application. That is it. Okay. So do not fall prey to the trap of UPSC that no prelims questions will be from science and technology module. Okay, this is the utmost requirement. So I am not going to talk about this module. I am not going to talk about biology module. I will be focusing on my module. Okay. Have you seen that the number of questions from physics and chemistry is only 1 to 3? That is why analyzing the cost benefit of the module, I mean after cost benefit analysis, we have decided for 6 classes. Means the process is important. There are high chances that you will get your question from these 6 classes, but you can't be very sure because UPSC's domain is not defined. So we just prepare our module means how we have designed the classes. So design of the classes is based upon NCERTs, because NCERTs are the most important book list or booklet you are having. Apart from that, we also cover some important topics which are not covered in NCERTs, right? We will also go for some important topics, okay, which are not covered in NCERT. Understanding this? Next thing about this is we also analyze the trend of UPSC. Analysis of trend of UPSC means what UPSC has asked to date and what UPSC may ask in coming times. So after analyzing means previous year questions. So this is the basis of our design of module. Okay. By this we have selected few of the topics and also some topics, important topics means for understanding some important concepts in technology or even in physics and chemistry. So this is what we have designed. Okay. Now physics and chemistry module is further divided into 2 modules. One is your static, okay, and other is your cosmic physics. Static module, okay, if you see up to 2015 UPSC was more interested in static module. After 2015 UPSC has changed its focus. There are high chances, 90% of the chances, that whatever the questions you are getting from physics and chemistry module, that will be reflected from this cosmic physics. 90% of the chances are this, that you will get your question from cosmic physics as per the trend of UPSC. But provided UPSC is unpredictable public service commission, so you cannot rely upon the mood of UPSC, because UPSC has more mood swings than you can expect from your girlfriend, right? No gender remark, just saying, and not any personal experience, just come here, okay? So this is after, means I'm saying that UPSC you cannot trust, because the trend of UPSC is very different. So it may be possible that next year you get questions from here and none of the questions from here, okay? Slightest of chance, but it can be. Like Earlier UPSC has asked questions from physical change, surface tension. I'm just writing the topics they have touched. Surface tension, rainbow, okay, illusion, optical illusion, etc. But after 15, I told you cosmic physics is more into focus. For example, they have asked question from black hole. They have asked question from theory of relativity. They have also touched Big Bang, etc. Now if you see, whatever you are finding the topics over here, these topics are really complex. We will deal with it. After Higgs boson got Nobel Prize, okay, most of the Nobel Prize in physics is awarded in the arena or the domain of cosmic physics. If you see, last year the award was given for dark matter. This year award is somehow related with black hole. Understanding this? So that is why I told you this domain is more important. Now there will be group of people or chunk of people who will be thinking that we should not focus upon this static module. We will directly come for the cosmic physics module. This is up to you. I am not going to say anything on this. But yes, I will just warn you that UPSC can anytime switch to static module. This is the first reason that you should not miss any class. Second thing, in static module itself, I will be teaching you some equations or some concepts which will be used in cosmic physics. For example, if you are at home at electromagnetic spectrum, there is no need to watch the lecture. If you know the dual nature of light, there is no need to watch lecture. It is not entirely based upon NCERT. I told you. If you know about quark, lepton, antimatter, etc., like things, beta radioactivity, etc., there is no need to watch these lectures. If you are not knowing this, or if you are having some blur memory in your head, please follow the lectures. It will help you. Now the most important thing comes, book list. Often it is asked and I don't know what to say, but I will say, okay, I'll write here. So as far as book list is concerned, I will go for tailor-made approach. Okay, there is no need. I will not say, suppose class 6 to NCERTs, class 6 to 10th, everybody has read science NCERTs, right? If your retention is less than 30%, means you have forgot most of the things, I would recommend please read class 6 to 10th NCERTs of science. If your retention capacity is between 30 to 60% or 70%, you say, not 60, 70%, please go for 9th and 10th NCERTs. If your retention capacity is more than 70%, you can only rely upon classes. Okay? You can only rely upon classes. You can skip NCERT. You can shift your focus to other important subjects like polity, etc. Okay? But this is how I would recommend the book list. Because there is no credible source also, okay? And not well compiled also. Apart from this, my request would be to go for MCQs, multiple choice questions. In Vision IAS All India Test Series, okay, when there is one set that is only for general science and full length tests, they will have questions from general science. So I would suggest you to solve MCQs. You can go for previous year's All India Test Series also, that will also help you. But without solving MCQs, you will not be able to deal with these concepts. Even at our All India Test Series, you will get some questions which will not be asked by UPSC anywhere, but elimination, solving the question, the strategy, etc., that you will get via this, that is very important. Now for cosmic physics, NCERT is not sufficient. Okay, space.com, etc., like website, NASA website, etc., you can read. But since internet is a dual-edged sword, you can waste your time. So I would say that please, because we are giving 2 classes for cosmic physics and 4 classes for this static portion. Okay, so within 2 classes I will be covering entire cosmic physics in detail. So it will be covered in class itself. You have to just update yourself with current developments. Just keep yourself updated with current developments. Rest everything about cosmic physics will be done in class. You need not worry for that. Okay? Take it in your head that static portion I am covering in 4 classes. So my speed will not be very slow. My speed will not be very fast. It will be so that most of you are able to do this. If you are unable to compete with my speed, please let me know. I will try that I can go slow. Second thing, try to read NCERTs, because if you have forgot everything, definitely introducing the thing in between will be complex for you as well, for me as well. And science is not like polity or anything else. Science will require some head to understand. Okay. Second thing, I will try to make things very lucid. I will try to make it very simpler. I will try to deconstruct the topic and try to relate it with your general surrounding so that you are able to understand it in a better way. Because understanding the concept is important, not understanding it in its technical terms is important. Is it fine? So this is how our course is designed. So for the next 6 classes we are here for you, and this is what is the scope of the class. Like it will be helpful in prelims and understanding some concepts of geography as well as technology. Why I am saying this? Because geography and technology have some physics concepts in it. So you cannot deny that they will not be having some overlapping domain. There will be some overlapping domain, and I will be telling that if you need to look into that topic when those modules are getting started. This is what is agenda of the day. I am very sure that I will not be able to complete everything today, but we will try to finish at least optical illusion. Let's see how far we are able to reach. My first question to you is, what is a wave? First we will understand some terms. After understanding those terms, we will enter in the main topic of the day. Okay, what is a wave? First question. Wave is nothing but disturbance in any medium, right? Wave is nothing but disturbance in any medium. Suppose you have a stone in your hand and you throw it in a pond or a water body. You find there are many ripples formed, right? Circular ripples, those are moving forward. Have you ever tried this? That is nothing but a wave. So wave is nothing but disturbing the medium. If you have disturbed the medium, it will have some ripples known as wave. A wave is defined by a curve. Generally, a wave is defined by a curve. Okay, a wave is defined by a curve. A sine curve or cos curve, any curve it can be, right? Let me make it once again. So it is defined by a curve, any curve it can be, sine or cos. So this is what is a wave. A wave has some property, for example wavelength, and frequency. Now we are going to deal with these concepts. So wavelength is what? Wavelength is the distance after which wave repeats itself. If you see here, if this is a curve, so this curve is getting repeated after this event, and after this event. Can I say that this part of the wave can overlap upon this part of the wave, and this part of the wave can overlap upon this part of the wave? So each of this part is known as waveform, and length of this waveform can be known as wavelength. So wavelength is nothing but distance after which wave is repeating itself. I will be dictating you notes, okay, but notes will be very point formatted because it is for prelims, and whatever I draw on board, it is expected that you should draw it parallelly, okay. So this is what is wavelength. Now suppose there is one more wave, I am just making below this, just for your understanding, no issues. Okay. Now you can clearly see here, this wave is getting repeated after this event. Okay. So this particular length over here is wavelength for this, means after which it is repeated. So wavelength is what? The distance after which it is repeating itself. Okay. Just write wave. Wave is any disturbance in a medium. Wave is any disturbance in a medium. Next point to write wavelength. Right. It is the distance after which wave is repeating itself. Is repeating itself. Now write frequency. I will make you understand this. Write frequency. Right. It is number of occurrence of event per unit time. It is number of occurrence of event per unit time. Occurrence of event per unit time. Let's understand what I told you. Suppose there is a guest who visits your house every month, and there is another guest who visits your house once in a year. So the guest who visits your house once in a month is having more frequency than the guest who visits your house once in a year, because that guy visits once in a year and this guy visits once in a month. It means 12 times a year. So that is why the person who visits 12 times a year is having more frequency, right? So number of occurrence of event, right? So we will say that the guest who visits your house once in a month is having more frequency than the guest who is visiting your house once in a year. That is why he earns less respect also. Is it fine? Means wavelength and frequency are antagonistic. You can remember like this. I will tell you. So suppose there is two trains. Just think by your head. One train is approaching, both trains are approaching you, and you are in between from different direction with same speed. Suppose the train is coming from 500 meter and the other train is coming from 1 kilometer. Okay. So definitely you can say that that train which is 500 meter away is able to send sound signals more frequently. That is why you find that that train is nearer to you. I hope you are understanding. Because if the train is moving, definitely there will be sound, okay? Sound waves will be created, and sound waves will be reaching to your head or to your ear more frequently by the train which is 500 meter away. But the train which is 1 kilometer away will send signals slowly or not that vigorously or strongly. That is why you will find that that train is nearer. So frequency is what? Frequency is measure of the number of occurrence of event. If something is approaching you, you can clearly say frequency is increasing. That is what, yes? Remember this concept. I will use this in cosmic physics. Rajat is asking to dictate slowly. I won't be dictating much slower than this. Okay, why? You are RB1. I expect more, more from you. From RB8 also I have been dictating at this pace. If you are finding that my teaching speed is fast, tell me. My dictating speed is normal, I guess. Okay. So I won't be dictating because only you have to write 1 or 2 lines. Second thing is this, that we are dealing with the concept. Okay. If understanding is slow, understanding is getting affected because of my pace, that is okay. You have to write 5,000 words when you will be going for writing mains, right? And that requires a lot of speed. Within 1 hour, you have to write around 1600 to 1700 words. So that is a big thing, and that also by thinking. So please do not ask me to dictate slowly. So now understand the wavelength, frequency. Now suppose you are at this place. Just think, you are at this place. And if you have to reach at this place, this is suppose place A and this is suppose place B. And suppose this is not a wave but a road. So what you will do? You will travel through this road and you will reach at this point after traveling through this road. Don't you think during this travel you have covered 3 waveforms? This is your waveform 1, this is your waveform 2, means how many wavelengths you have traveled, and this is your waveform 3. Yes or no? So in this case, for the first case, 3 waveforms are covered. 3 waveforms are covered. Now suppose you are here in second situation. This is B and again this is A. So you are moving from this point, so move. So you will be covering 1 waveform, then second waveform, third, fourth, fifth, sixth, 7, 8, 9, 10, 11 and 12. So don't you think on this road or in this route we will have to travel 12 waveforms? Waveforms I can say also, 12 wavelengths it is covering, and here I can also say 3 wavelengths. Okay, 3 wavelengths. So just tell me, this axis is suppose time axis. So both are situated at equal time. Yes, both are situated at equal time. So within this time frame, this event is happening thrice because 3 wavelengths are covered, and this event is happening 12 times because 12 wavelengths are covered. Right? So from the picture you are having in front of you, you can clearly say that the wavelength of first event, this one, so wavelength of first event is greater than wavelength of second event. This wavelength is smaller than this or not? Yes? this wavelength is smaller than this wavelength. So I can clearly say wavelength of 1 is greater than wavelength of 2. Second thing is, I can also say frequency of 1 is less than frequency of 2, because its frequency is only thrice and its frequency is 12 times. B has to travel 3 waveforms, means it is occurring 3 times only, and here B is happening to travel through 12 waveforms, means it is happening 12 times. So these two equations give us a very important relationship, that is wavelength is antagonistic to frequency, means both are inversely proportional. You have to remember this, wavelength and frequency are antagonistic to each other. Okay, this relation is important from this entire graph or entire discussion, only this one. So wavelength is inversely proportional to frequency, just remember this. Okay. Now come to one more concept, that is called bandwidth. What is bandwidth? I hope that while watering your plants you must have done this, that putting a finger in front of the pipe. So what happens when you put finger in front of the pipe? The water flow is impacted. Okay, the water stream coming out of the pipe is narrow. And in second case, if you do not put finger, then what happens? The water stream coming out of the pipe is normal or broad. So bandwidth is nothing but capacity of the network. Okay, so bandwidth is, just write this, bandwidth is capacity of the network. I will make you understand this. First write, bandwidth is capacity of the network. Higher bandwidth reflects more capacity of the network, and hence more speed can be expected, and hence more speed can be expected. More speed can be expected. Now suppose I am going to tell you about bandwidth. Okay, so first understand what is bandwidth. Suppose this is your colony. Okay, this is suppose chunk of few houses. This is suppose parking area. This is suppose garden of. This is the park. This is again chunk of few rich people. So this is suppose your colony. And let's go back to time. Suppose year 2000. So there was no road in your colony. Because of that, many accidents etc. were happening. So what government did? Government left some space in front of your houses for drainage etc. and started constructing road. So government constructed road over here. So this is year 2000. So from your house's tram line, it went for 5 meter. Okay, 5 meter offset was taken, and the other side of the road was taken 25 meter offset. Suppose this is ground zero. Something should be ground zero. For example, you just measure the height of any place from sea level. We consider sea level to be ground zero, right? So it is 5 meter offset taken from the outer edge of the boundary wall and 25 meter here. So I can clearly say width of the road is 25 minus 5, that is 20 meter. So this is width of the road. So what happened? Vehicles started moving through the road and it was very normal, and it was good for the commuters also and good for the colony people also. Okay, time passed. So with passage of time, people had more capacity to buy. So many other vehicles came onto the road, okay, which led to the congestion or traffic on the road. Now the commuters were facing a lot of difficulty along with the people of your colony because there were too many vehicles on the road, right? So government decided that let's broaden the road. So it was 2020 when government decided to broaden the road. So the other side of the road was taken offset of suppose 45 meter. So now what happened? The road length became 45 minus 5, 40 meter, no, 45 meter from here and 5 meter from here. So the net width of the road will be 40 meter. Because of this, vehicles distributed on both sides of the road and congestion or traffic on the road was maintained or reduced. So you can clearly understand that width of the road needs to be increased with increasing traffic. But have you ever thought of digital traffic? Okay. For example, the devices you use today for communication are mobile devices. So every mobile, while communication, sends some signal. So this signal means has some frequency, because signal is nothing a kind of wave, and every wave will have some frequency. So suppose you are dialing a number, so any other person is receiving it, so both are exchanging or both are dealing on same frequency, right? So some frequency is sent, and you can very well understand that every person is having a mobile with dual SIM. So there is a lot of frequency traveling here and there, right? Apart from this, there are other devices which also use the same frequency range. Devices, which device? For example, microwave oven. For example, remote controls. Okay. Your smart devices, smartphone, smart watches, etc. Router. So they also follow same route. Because of that, there is congestion in the network, right? So now just think, this is not 5 meter, this is 5 hertz, because hertz is unit of frequency. I'm just making you understand, just be with me. And suppose this is 25 hertz. So in year 2000, the capacity of the network was only 20 hertz. Capacity of the network like capacity of the road. Because of that, only 20 hertz. I am talking about year 2000. So signals from mobile used to travel only through this route. Because of this, very less congestion in the network was observed, because people, not most of the people were having smart watches. That was not the time when smart watches were more popular, and not many people were having mobile phone. So you can clearly understand digital traffic was very less. But with time, people had smartphones with them. Apart from that, some devices were also in picture which were using the same frequency range or same network. Because of that, digital capacity of the network declined and we find lesser speed. Okay. For example, just 1 or 2 years back when Jio came with that plan, you were getting a high speed network or high speed internet free of cost. But today you are paying also, but that sort of speed is not available to you, because many people are using Jio network and they are using the same road or same bandwidth. So this capacity is known as bandwidth. So don't you think that congestion in the network will be there. This will compromise the network speed. Because of that, in 2020, government again decided, let's broaden the bandwidth or broaden the road, whatever you say. Because of this, some of the traffics, some of the digital signals will also travel through this route and traffic will be reduced. So this is the concept of bandwidth. Like you are broadening the road, this is how you broaden the bandwidth. So with this, let me introduce something. So our communication started with generations. First generation communication, second generation of communication, which you call 2G, then 3G, then 4G, then 5G. I will not teach you 5G, okay, because I have limited class to cover. But I am assuring you 5G will be covered either in current affairs, okay, it will be reflected in your current affair magazine or in science and technology class. So 1G was the time when you used to call. 2G gave you the facility of calling plus good morning and good evening, means SMS. But very slow internet. Internet was that slow that you used to type facebook.com and you used to visit nearest chai shop. You were knowing that within 15 minutes the web page will be opened. That was very slow internet. 3G actually gave you internet that can be used, right? After 3G, 4G came, that give you faster internet. And 5G is one step ahead of this, that is, it is talking about real-time communication, means more faster internet. So we are moving from 1G to 5G. One thing I can assure you, though there has been technological development, one thing you can be sure of, that bandwidth of the network has been increased. Right? Bandwidth of the network has been increased, that is, network capacity has been increased. It means what? Speed of the network has been increased. So this is what is the idea of bandwidth. See, bandwidth often comes but with this I would say that this is the most easy way to understand bandwidth, because most of the people are not aware of bandwidth. And time and again you will get the terms like frequency, wavelength, bandwidth. So I have touched them in detail so that you can have the understanding of the topic. Okay. I hope this is clear to understand. With road traffic, you can clearly understand this. Now let's move to the very important topic, that is light. What is light? Light is electromagnetic wave. Okay? Whatever is falling on your face right now that you are able to see something, okay? The light coming out of your laptop or mobile or even from this PPT. So light, you know, but light is again a wave. Which kind of wave? Electromagnetic. Just see in the PPT, the blue one is called electric field and the red one is called magnetic field. So both are moving in perpendicular direction. Okay, both are perpendicular to each other, moving forward. So light travels this way, where electric field and magnetic field both are perpendicular to each other. So what that mean? Electric field and magnetic field will be covered in next class. Those who are not knowing, they will come to know. But as of now, just know this, that wherever there will be electricity, there will be a field around it, like a magnet. For example, this is a magnet, so this magnet will have a field around it, yes or no? Suppose this is iron bar, so if iron bar is here, magnet is here, nothing will happen. But if you will make iron bar closer, after this it attracts it. Why? Because it entered in the magnetic field of this magnet. Okay. So magnetic field is the attracting force. In the same fashion, electric field due to electricity is attracting force. Okay. So light is electromagnetic wave. My next question to you is, which is the very important topic of discussion, whether light is a particle or light is a wave. Okay. My submission is this. Yes, light is both particle as well as wave. Are you able to see this? Yes, this happened in film also, and this happens in the life of light also. That light is both particle as well as wave. So we will first understand why light is particle and why light is wave. Then I will make you write. Okay. So first try to understand dual nature of light. This will be the topic. So light is particle also and light is wave also. Let's understand both nature one by one, starting from the wave nature. Suppose there are two walls. This is your wall 1 and suppose this is your wall 2. Suppose there are two slits or two narrow passages. So this is your passage 1 or slit 1 and this is your passage 2 or slit 2. And there are two shooters in front of both passages. Two shooters with gun. You asked them to shoot. So this shooter started shooting. Provided this wall is non-penetrable. Non-penetrable means bullet cannot enter or penetrate the wall. Okay? Bullet will only pass through the passage. In the same fashion, this gunman will also fire bullets. So what you can expect? You can expect that the patches of bullet will be found only at these two areas, patch 1 and patch 2. Yes? Only these two areas will have bullet patches. Right or wrong? Yes? Some bullets will be coming and slightly deviating, but you won't find ki yahan bhi bullet hai, yahan bhi. No, that sort of thing will not be there, because bullet will be traveling in straight line. And I told you that walls are non-penetrable. So wherever you are finding the slit or the passage, bullet marks will be here. I hope you understand. Right? Let's repeat the same event, but with different circumstances. Again we have wall 1 and again we have wall 2. Again two narrow passages and again two gunmen waiting. Now what we did, we just provided them light gun. Here it was gun, here we are giving light gun. Okay. Light may be, that is monochromatic light. Monochromatic light means only one colored light. Okay, but you can understand light gun. Okay. Those who are knowing this, keep it with you. Monochromatic light means only one shade of light is taken. So light gun is there. So they just hit through the slit. So they are hitting through the slit. So again, you can expect that light should be found only at these two patches, patch 1 and patch 2. So light should be found only at these two patches. This is what your general understanding is this. But it was observed that light was available throughout the wall. Means light was available throughout the wall. Somewhere the intensity of light was maximum and somewhere it was entirely dark. Okay? So somewhere very bright, somewhere normal, and somewhere it was dark. So alternate patches were found. Somewhere it was dark, somewhere it was means high intense. So this was the experiment done by Young. So it is known as Young's double slit experiment. So Young said that looking at this picture, or this observation, we can clearly say that light is a wave. Light is not a particle. So what Young said, that this light is not coming in a straight line that you are thinking. This light is not coming in a straight line that you all people are thinking. He said that light is a wave. How wave travel? Wave travel in a circular fashion. बेहतर मार्कर है थोड़ा ब्लू वाला, चेक करवा, ठीक है. So you can clearly see, whenever you throw a stone in water body, circular water ripples are formed, right? So circular water ripples are formed. So I can clearly say that wave will move forward in a circular manner. So Young said that it will move in a circular manner. Is it fine? So from here it will move through circular manner. I am just taking semicircle because taking entire circle will make the diagram, very messy. Okay. From here also this will move like this. So at the slit position, it will again enter like the wave. So these two waves will interfere each other. Because of this, you will find bright, normal or dark patches on the entire wall. So this suggests that light is nothing but wave. Though the understanding of Young is not completely correct, but if we want to prove light as wave, this is what is the best observation. So please write wave nature of light. Then we'll go for particle nature, right? Young in his double slit experiment deduced the wave nature of light. Deduced the wave nature of light. Right. It helps us in understanding the bending of light, comma, refraction, comma, light as energy carrier, etc. Okay. Now just try to understand what I made you write. For example, light bends around any object, okay, or light shows phenomenon of refraction. Suppose you are having mustard seed in your hand. Mustard seed, everybody knows, a very tiny seed, okay, can often be found in your kitchen, sarso, okay. And if there is a glass, transparent glass, if you will put light on it by a torch, light can be seen on other part of the glass as well. What happened? Light refracted from the glass. But if you will throw mustard seed on that glass, you will find what? You will find that mustard seed is getting reflected in the medium. It will not it will not enter the glass and it can be found that side. Understanding this? So refraction means light is changing the medium. This is what is showing what? The wave nature of light, that refraction. Okay. Now let's discuss particle nature of light. So particle nature is something, okay, particle nature is something what we call, which has property of collision. For example, when you threw mustard seed, it collided with the glass and it remained in the medium, right? So it has the property of collision, particle nature. Particle has more energy because particle, when something is particle, for example, you, I, everything is particle. So particle is contained form of energy. So particle will have more energy than wave. For example, if you want to hit someone, what you are going to do? You are going to hit him by your hand, or you are going to hire some people who can hit him. You are very much annoyed. No one will do one thing, that they will accumulate or they will get 10 mobiles with them, and using the waves of all 10 mobiles they are going to hit that person. Those waves are not going to harm him in that way. Even the gamma radiations will be harmful to them provided their frequency is too high, right? Though it is very much harmful, but I am telling you that particle will have some accumulated energy that has property of collision. So Einstein exploited this property. What he did, he took a metal surface. Okay, just understand this. He took a metal surface. Why? Because metals are having free electrons on their surface. Why he took this? Because metals are having free electrons. Then he did one thing. He just bombarded light of specific frequency. Okay, he bombarded light of specific frequency. What he observed? He observed that electron came out of metal surface. So when electron came out of metal surface, Einstein said light is a particle. Einstein has given a lot to science. For example, photoelectric effect, Brownian movement, theory of special relativity, theory of general relativity. Every other experiments or deduction of Einstein, okay, gave him name and fame. But it was only photoelectric effect that gave Einstein Nobel Prize. Okay, Einstein has got Nobel Prize only for once, and that also because of this experiment, that is photoelectric effect, that I have told you right now. What Einstein did? He took a metal surface because there are free electrons, and light of specific frequency was bombarded. Because of that, electron came out of the metal surface, right? So this experiment deduced the particle nature of light. Now you will say that why Einstein said that this is particle nature of light. There is no collision, okay, but Einstein said yes, there is collision. He said that light you are understanding is not that way. Light is actually packet of photons. It is not the continuous stream that you are finding, it is packet of photons. So there are millions of packet of photon. For example, this is first, second, third, fourth, fifth, sixth, going to millions of photon. So there are chances, as per Einstein, that any one of the photons must have collided with any one of the electrons. Because of that, electron came out. So Einstein's deduction was any one of the photons must have collided with electrons to eject it out of metal surface. I do understand this is difficult to understand. Just take this example. If you are taking shower, so what happens? You find continuous stream of water is coming on your head, but you are knowing that water is not continuous. Why? There are millions of water droplets which are coming together via cohesive force, let it be. Those are coming together, right, to give you continuous stream of water. So that continuous stream of water is nothing but what? That continuous stream of water very sorry, is the accumulation of millions of droplets. In the same fashion, the continuous ray of light is nothing but packet of photons. Like water droplets are making continuous stream of water, similarly millions of photons are making continuous ray of light. So that is why one of the photons must have collided with electron to eject electron out of metal surface. So this is particle nature of light. So whenever we are talking about photon, it means we are talking about particle nature of light. Okay, so please write it. Light as particle. Give heading light as particle. Right. Einstein in his photoelectric effect experiment deduced the particle nature of light. In this experiment, he found that light of a specific frequency was able to eject electron out of metal surface. Okay, out of metal surface. Particle nature of light helps us to understand okay, help us to understand why light travels in a straight line, helps us to understand why light travels in a straight line, comma, phenomenon like reflection, etc. Why light travels in a straight line, comma, phenomenon like reflection, etc. Phenomenon like reflection, etc. Phenomenon like reflection, etc. For this particular experiment, Einstein was awarded Nobel Prize. For this particular experiment, Einstein was awarded Nobel Prize. Okay, just see the PPT. I have told you this Einstein's experiment that light of specific frequency is able to eject electron out of metal surface, right? And this is double slit experiment of Young in a funny way, that you just sent monochromatic light and bright and dark patches were found. Yes, so this is what is Young's double slit experiment, just in a funny way. Do not go that. Now the most important part, electromagnetic spectrum. Please try to understand it, because this relation is very much important. You can anytime expect a question in prelims or test series. You can solve that question if you are having clarity of electromagnetic spectrum in your head. Okay, so we'll start electromagnetic spectrum. There is a question from Rohit. Sir, is it true that we have never measured the one-way speed of light? We have only measured two-way speed of light and then average, which we call the speed of light. Rohit, actually speed of light is very difficult to obtain, right? So starting means when it was Galileo, he thought that the speed of light is infinite. Then some other experiments were done, but nowadays the most accurate form of speed of light is known, which is correct up to an error of 1 meter per second. So a mirror was taken and the laser lights were taken and atomic clocks were taken to deduce, right? So this is how it is measured. That light will be getting reflected, the laser will be getting reflected, and atomic clock will be measuring. Why we are taking atomic clock? Because synchronization is problem. Every time the speed of light was calculated, every decade or every 20 years, there were a group of scientists. For example, after Maxwell, we find that the speed of light was measured to its correction, but always there were difference of 1000 or 10,000 kilometer per second. So that difference was nullified when lasers were invented and atomic clocks were in picture. So that is how we know this. Okay, I don't know that why you have asked this question. This is not the right approach right now. We are having correct measurement of light. The speed of light 2.99792458 meter per second. Roughly you call it 3 lakh kilometer per second. Okay. Let's move to electromagnetic spectrum. I am making it, you also make it parallel. Everybody knows what is rainbow. Yes, rainbow, colorful. We'll see after the break also. VIBGYOR. These are the 7 colors which are reflected in rainbow. Okay. So just make VIBGYOR on your electromagnetic spectrum. Heading is electromagnetic spectrum. After red you have to just make infrared. Infrared wave, you must be knowing the name at least, right? And beyond violet, it is ultraviolet. Ultraviolet ray, it is written, right? Beyond ultraviolet, it is X-ray, and here it is gamma ray. After infrared, we are having microwave, and finally we are having radio wave. If you remember the name also, that microwave, radio wave, X-ray, gamma ray, then also you can arrange it on the electromagnetic spectrum. For example, this entire setup is known as visible light. VIBGYOR. All colors coming together give you white light, and that white light you are able to see right now. So this is visible light. So after red you have to write infrared. Infrared is having wave in its name. So all waves will be written this side. Are you able to see? I have written wave, wave, wave. Here I have written ray, ray and ray. If you observe this, your electromagnetic spectrum is also calling the dual nature of light. It is also calling for dual nature of light. These three are, you can say, high energy radiations or high frequency radiations, whatever you say. And that is why they will also show you particle nature. Try to understand this, what I am making you see. And these infrared and microwave and these three are known as low energy radiations. And hence they are having wave nature in them. If you see, Einstein said in his experiment, light of a specific frequency is able to eject electron out of metal surface. Right? Gamma, X or ultraviolet. Even the slightest of intensity or the dim intensity of these rays will be able to eject electron out of metal surface. But higher intensity of infrared, microwave and radio wave will not be able to solve the purpose. That is why these are having low energy. That is why these are having wave nature. These won't be able to eject electron out of metal surface. If you want electrons should come out of the metal surface, definitely high energy radiations like gamma, X or ultraviolet can do the purpose. These cannot. Is it fine? Now looking at the picture, here I am writing wave, here writing I am ray, it means it is particle nature, it means it is wave nature. Can I say if I am moving this side, wave nature is increasing or not? Wave nature is increasing. Yes, it is increasing. If wave nature is increasing, I can clearly say wavelength is increasing. Yes, wavelength is increasing. If wavelength is increasing, you can clearly say frequency is declining. Wavelength and frequency were having antagonistic relation. And if frequency is declining, you can also say energy is declining. High frequency means high energy. So these radiations are high frequency radiations, gamma, X, ultraviolet, and hence high energy radiation. Gamma ray and X-ray are known as ionizing radiations. Rest others from ultraviolet to others, these are known as non-ionizing radiations. Ionizing means if something comes in picture, they are broken into ions, means charged particles. Now we will see the application of these waves. Okay. First draw, I will just give you 1 more minute. Now one thing you keep in your head, if I am writing particle nature, it doesn't mean that these are not having wave nature. These are also having wave nature, but particle nature is more prevalent. Understanding this, for example, if we say that that is a very calm guy, it doesn't mean कि उसको गुस्सा नहीं आएगा, right? But that is rare. In the same fashion, particle nature means wave nature is minimal and particle nature is more prevalent. Okay, now make a table. This side you write wave and this side you write application. Okay, this side you write wave and this side you write application. First, you write about radio wave, right? Radio wave, right? As the name suggests, radio waves. Why? Because it was used for radio communication, right? Radio and TV communication. Radio gets its name from radio wave only. So, right? Radio and TV communication. Next you write Bluetooth. Bluetooth. Next to write submarine communication. Submarine communication. Submarine communication. Next way we are having microwave. Keep adding microwave. Right. Mobile communication. Mobile communication. Microwave oven. Microwave oven. Everybody knows oven? Microwave oven. Okay. Now I will explain a very interesting feature of microwave, but I will not dictate. If you want to write, you can write in your own words. So let's talk about microwave. How microwave works? Why microwaves are used in oven? Why we cook food through microwave, not other waves? So there is some property, that property we need to understand. Actually, microwaves have great affinity towards water molecules. Listen to me very carefully. Microwaves have great affinity towards water molecules. So whenever microwaves come in contact with water molecules, they vibrate it. Vibrate it means they transfer their energy to the water molecules. Because of this transfer, water molecules get heated and cooking of food is supplemented. Just say this. If you want to boil potato, what you do? You take a pot, you put it on the gas stove and boil water, put potato into it. The potato gets cooked. Very easy. In microwave what you do? You just put the potato and microwave it. It will be cooked within a minute. There is no need to put water in a pot. Why is it so? Because potato is having moisture in it. Right? So when potato is having moisture in it, so microwaves interact with the moisture. Moisture means what? Water molecules. So microwaves interact with the moisture, that is water molecules in the potato, because of which that water molecules get heated and potato gets boiled. So this is what is the idea of microwave. That microwave have strong affinity towards water molecule, they transfer their energy to the water molecule. Okay. Have you ever been to big shops, okay, like Agarwal Sweets, etc.? You will find that they have made samosa, okay, and they just microwave it before giving it to you, right? So what is the idea? They just take a plate, put samosa over the plate is of paper, okay, mostly hard paper, and they put it in microwave. After 1 minute or so, you get garam samosa, right? But the plate is not hot, okay? Samosa is hot, but the plate is not hot. Why is it so? When you put samosa in the microwave along with that paper, samosa is having some masala filled in it. That masala is having moisture in it. So the moisture interacts with microwave and samosa becomes hot. But the plate on the other hand, the paper plate is not having moisture in it. That is why it remains cool. So I hope you understood microwave. Now let's come to infrared. Infrared. Right. They are carrier of heat from sun or fire. Right. Infrared are carrier of heat from sun, fire, etc. or any hot object. See, you wash your clothes become dry, whether you put it on under sun or you put it in your room. Okay, if you are putting it in your room, it will take some time, but under sun it will be dry very quickly. Actually what happens, infrared are the heat carrier, means the heat from the sun reaches earth because of these infrared waves. If these infrared waves will not be reaching earth's surface, take it from me, once wet is always wet. Have you heard? Once a soldier is always a soldier. That will happen. Once wet will always be wet, right? Because infrared, if they will not be reaching earth, definitely the capacity of earth, the heat capacity or heat budget of earth will be compromised. Okay, so that is the thing. Infrared waves are also used in TV remote. Nowadays microwaves are also used in TV remote, so there is no problem, but infrared are used in traditional TV remote, so you manage that way, TV remote. Now let's come to ultraviolet. Ultraviolet, you write? Right. It kills bacteria or viruses. It kills bacteria or viruses. Next you write, ultraviolet synthesize vitamin D from our skin. Ultraviolet synthesize vitamin D from our skin. Ultraviolet synthesize vitamin D from our skin. You must be wondering, okay, that why I am saying ultraviolet does so. Ultraviolet is supposed to be harmful. If you are having this doubt, then post me, else let's move forward. One more thing, in biology you must have told that synthesis of vitamin D is under sun. So under sun it is ultraviolet which does the purpose. Now come to X-ray, right. X-rays can penetrate your body, all the tissues, but it cannot penetrate the bone. Because of that, deformation in bone can be detected via X-ray. So just right, it is used to check for bone deformation or deformity. It is used to check for bone deformation. It is used to check for bone deformation. Next point you write. Okay. Have you ever been to airport or metro station? There is a box. Okay, you put your bag in that box and they allow you to move forward, that there is no threatful thing. Because those boxes are security scanners having X-rays in them. So X-rays give them the clear picture that what is inside the bag. Okay, so just write it, X-ray at airport or metro security scanner, used in airport or metro security scanner. Airport or metro security scanner. Gamma ray for cancer therapy. Gamma ray for cancer therapy. I am going to tell you about UV. Okay, you have not asked, but I will tell you. Suppose this is the surface of Earth, and suppose this is ozone layer. Okay, ultraviolet is having 3 different shades. Ultraviolet A having lesser frequency comparatively to ultraviolet B, ultraviolet B having lesser frequency compared to ultraviolet C. Ozone layer reflects ultraviolet C 100%. Okay, nothing enters in Earth's atmosphere. 99% of UV is reflected. Only 1% is allowed to enter. And here also around 40% to 50% is reflected. Rest other is allowed to enter. UVA and UVB are harmful to, UVB and UVC are harmful to humans. So ozone C does not allow to enter them. Only 1% of UVB is allowed, rest 99% is also. Okay, so this UVB can lead to cancer. Yes, Sandeep has asked this, skin cancer. So this UV can lead to skin cancer. That will depend upon the frequency, right, UVB. But UVA is not that harmful. That is why you are asked to stay under sun. Okay. So now there is a very short break. I will not be giving you very longer break. Purpose is that if I will be giving you break for 10 minutes, then it will be 1 hour in 6 classes. I have been assigned 6 classes to finish the thing, and if I will breach the limit, then definitely your course will be delayed, and that is not required. So our break will be maximum 2 to 3 minutes. So please do not request me. I am also having some obligations. Okay, classes are there after 1:30. Okay, so they will be also arranging, because at 2 there is class, so we can't stretch the class also. So I have to finish. I will start on time, I will end on time, and very short break will be there. So I am just giving you a question. So this is previous year question. You try this, okay, and send your response to the coordinator. Just coming up after the break, I will discuss it. Thank you. Okay, waiting for your responses. If you have got whatever the questions you will find on the PPT, 90% of the questions are previous year questions, so that you can check your preparation. Okay, Niharika has said that blue marker is not visible. Actually, Niharika, I have asked for change of marker. Okay, again I have asked for change of marker. So let's see that if that is visible. Rohit, Anutosh and Rajat have given option 1, it means option A. Okay, Sandeep has gone for option 1 and 3, any option C. Okay, I have made you written what? Ultraviolet kills only the bacteria and virus. So this only inactivates or kills the microorganism. Option 2 and 3 is wrong, because ultraviolet will not have that much power to remove the turbidity or the smell. If you are having this doubt in your head, this is because of osmosis. So osmosis or reverse osmosis process will be taught to you in chemistry class. Okay, I will be teaching you osmosis or reverse osmosis. Because of that, water is getting cleaned. So only option 1 is correct. Palash has also gone for the right response. Ray optics. Okay, we are going to start ray optics. I have to finish up to optical illusion. Let's see if we are able to. If not, we will continue in the next class. Okay, take it from me, very important. But UPSC is not asking nowadays, but up to 2015-16 there were questions, many questions from this particular topic. We will do it because we do not know the mood of UPSC. Don't consider that I will be dealing with what you say, formula, etc. I told you. So just see the beauty of nature. So this is all because of the reflection. Okay, everywhere you are finding the reflection of water body is there, right? Okay. Now see the medium interface. What is reflection? First let's try to understand this. Suppose this is medium interface and I am just drawing a normal. Normal is nothing but a perpendicular line. Okay. This is just a revision exercise. Everybody knows reflection. Revision exercise. Suppose a light is incident at this point and light cannot enter into another medium. Suppose it is painted. So light is bound to reflect back in the medium, right? So when light is incident and it is returning or bouncing back to the same medium, the phenomenon is known as reflection. So reflection is the phenomenon in which light remains in the same medium. This is the most important idea. Okay, just write this reflection very quickly. It is the phenomenon in which light or sound or heat waves enter in the same medium. Sorry, heat waves return to the same medium. Heat waves return to the same medium. That is the medium remains the same. That is, the medium remains the same. Now let's talk about refraction. So I have made refraction in this slide only. Focus on the PPT. Now suppose light is entering in the another medium. So do you expect light to travel in the same line that it was coming, or you expect that light should bend? Definitely light will not travel at the same angle, or it will not travel through the same path it was coming. Why? Because the density of the medium will not be same. If density of both mediums will not be same, there will be slight difference. So either light can bend okay, rightwards or leftward. Are you getting this? Either light can bend rightward or light can bend leftward. Let's understand this. Now please tell me if blue marker is visible or not, because I don't know. I have asked for replacement and this is replaced one. So this incident ray is coming. So as per your expectation, this should travel through this line. No, it will not. Why? Because density of the medium will be changing. Now just think, you are traveling on a road during festival, or so festival means what? People will be on road. So more people will be on road. So if more people are on road, you can say that density of people on road is more. Means high population density is on road. And if density is more, I hope the speed of your bike will be less. Else you will hit someone and you will be hit by the public. Yes? Now come to second thing. Suppose you are traveling during lockdown. So lockdown what? People will be forced to stay at home, means less people on road. It means what? Density at road will be less. That ensures you can have more speed because road is vacant. In the same fashion, if I take these two interfaces, suppose this is medium 1, this is rarer medium. Rarer medium means lesser density compared to denser medium. And suppose this is denser medium. That is, it is air. Suppose air is rarer, and suppose this is water. So what I can expect, that if it is moving from rarer to denser means what? Speed should decline. Means it is moving from the road of lockdown to the road of festival, because density is increasing. We are coming means density is increasing. So speed is bound to decline. So speed will decline. So decline means, speed means what? It is coming near to normal. Just see this. It was here, it deflected this side, means it is coming to normal. Take another example. Another example means, suppose this was water and this was air. So this is comparatively rarer medium. Again the ray was coming, so speed should increase because from festival to lockdown. Lockdown means open road. So speed should increase. It means it is going away from the normal. So what deduction I found? The deduction I found was, if you are moving from rarer to denser medium, speed of light is bound to decline. This is first observation. And second observation, it will move a bend towards normal. Normal means the perpendicular line. I hope you are understanding this. Okay. And if you are understanding this, please write, then we will discuss a bit more. Please write. When light travels from one medium to another, when light travels from one medium to another, comma, it changes its path. It changes its path. And how it changes? Please write this. Rarer to denser and vice versa. Okay. So rarer to denser and vice versa you have written. Now write. Next point. In refraction there is no change in the frequency of wave, but the wavelength and speed changes. No change in the frequency of wave, but wavelength and speed changes. Change actually, not changes. Wavelength and speed change. Understand this thing. Why speed is changing, you understood? That is medium density difference, right? I told you wavelength is changing but frequency is not changing. You will say, sir, you told us that wavelength and frequency are antagonistic or inversely proportional. If one is changing, other should also change. But consider it, the medium has changed. So if there is change in medium, we cannot expect the relation to hold true. So I hope that why wavelength is changing is understood, right? When the medium is getting changed, this relationship will not hold water. Okay? The wavelength and frequency will have the relationship if they are in the same medium. Okay? For example, there you are the boss and there is a subsidiary. Okay? If the subsidiary, you are an IS officer, gets the transfer to another department, you cannot have the control on that. Okay? He will not be the subsidiary of yours. In the same fashion, since the medium is changing, you cannot expect the relationship to be true. And the frequency one, that is proved by Snell's law, but that derivation is not required for us. So that is why I am telling you the simplest explanation, you should buy it. Okay, do not ask me to derive it. I am not going to derive it and it is not required also. So whatever I am telling you, please consider it. Suppose this is the point where light is incident. Okay. Frequency means what? Incoming and outgoing. Number of occurrence of event per unit time. So if the number of incoming event and number of outgoing event is same, it means frequency is unchanged. So here light number of waves coming per second is equal to the number of waves going out per second. That is why frequency remains same. The incoming number of waves is equal to the outgoing number of waves. Okay, avat and javat, both same. Incoming and outgoing, both are same. Okay. Now understand it in a better way or very easy way, PPT. Okay. So there is ray. Ray means what? Kiran. Okay, ray is called Kiran in Hindi. So suppose Kiran is coming at the marriage interface. She has two options with him, Sunil and Rahul. Sunil is your Sunny Deol and Rahul is Shah Rukh Khan. Naam to suna hi hoga. So that is the same thing. So suppose Kiran is at marriage interface and she chooses to be in the marriage, means with Sunil. This is reflection, not changing the medium. And if she goes with Rahul, she is changing the medium, it is refraction. So reflection and refraction can be differentiated by this one stark difference, that if it is within the medium, reflection, changing the medium, refraction. This is as simple as this. Now let's discuss dispersion. Dispersion means what? I told you white light is accumulation of 7 colors. Are you able to see this? Vibgyor. So if these 7 colors come together, they will give you white light, right? But sometimes it so happen that white light break themselves into 7 individual colors. The phenomenon is known as dispersion. Just write dispersion. When white light passes through a prism, it splits into 7 individual colors. It splits into 7 individual colors. Right. This happens because different colors have different speeds through any medium. Different colors have different speeds through any medium. Different colors have different speeds through any medium. Just see the prism. Okay. In prism you can see the red one is deflected the least and the violet one is most deflected. Red one is having slightly higher speed, that is why the deflection is less, and the violet one is having lesser speed, hence the deflection is higher. So this is all about dispersion. You should know the terms actually. When we will be doing the application, for example when optical illusion will be started, mirage, then I will be telling refraction, reflection, so that terminology is important. That is why I am revising it. This is just a revision exercise that is going on. Okay. Now we are going to do a very important topic, that is Rayleigh and Raman scattering. So first we will start with scattering of light, that is Rayleigh scattering, then we will proceed for Raman scattering. So I want your attention for the next 15 minutes throughout the PPT and the board. Please do not interfere in between. If after 15 minutes you have not understood the concept, then intervene. Okay. So I request you to focus on the PPT first. I will make you write. Do not write anything. Scattering of light. We are starting with Rayleigh scattering. Suppose this is very sorry. Suppose this is sun. So from sun light is coming. Light is suppose coming towards earth. Light will have to travel the atmosphere, right? So light reaches earth by traveling a larger distance, but there are obstacles. Let's see what happens. So light is coming towards earth. The animation is made so that online classes should not be a burden. So light will be having, the white light of sun will be having longer wavelength also and shorter wavelength also. That is red and blue. Longer means red and shorter means blue. But in our atmosphere, suspended particles are there. Suspended particles like dust particles. So these dust particles create obstacles in the way of light, right? ऊंची ऊंची दीवारों से इस दुनिया के रस में the same thing is happening. So both events happen simultaneously. That means red one and blue one both will interact with dust particle and scattering phenomena will happen. But here we will understand it one by one. First we will understand for red one, then we will understand for shorter wavelength, that is blue one. So what happens to the red wavelength, means longer wavelength, when it collides with dust particles? So when it collides, what happens? Scattering is very less but intensity declines. Means what? Even if you are Hrithik Roshan, just remember like this, and if you travel through coal mine or an area which is full of dust, you will appear like Nawazuddin Siddiqui. Why? Because all the dust particles or black carbon will sit on your face. That is going to impact your intensity or your charm, right? The same happens with red light. Red light is having great intensity, but since it collides with dust particles, so intensity declines, right? Now second, when short wavelength, they collide with dust particles, they scatter a lot, okay? So here what happens? Scattering happens, and since scattering happens, intensity increases. Now suppose this is 1 liter of water accumulated at one place. Suppose I open the bottle and scatter the entire, okay, scatter the entire water. So if a scattering of water will be there, I will find everywhere water. But if water is accumulated at this place, I will say very little water. Yes or no? So if scattering happens, intensity increases a lot, right? So here one thing you need to remember in Rayleigh scattering, that what you need to remember, intensity of light or scattering is inversely proportional to wavelength. Exact relation is wavelength to the power 4, but you can remember by wavelength on. Means longer wavelength will be scattered least and their intensity will be least. Shorter wavelength will be scattered more, their intensity will be more, right? It is observed that the difference between intensity of red and blue is almost 10 times. Means blue is 10 times more intense or more bright. That is why sky appears to be blue. Sky appears to be blue because of this Rayleigh scattering. One more observation that you can see over here, that if red wavelength is colliding with the dust particle, you are getting red wavelength. If blue wavelength is colliding with the dust particles, you are getting blue wavelength. Red is getting collided, you are getting red. Blue is getting collided, you are getting blue, right? So that is why this is known as elastic scattering also. Okay, I will make you write, don't worry. That is why it is known as, see the PPT, elastic scattering. Why elastic scattering? Because scattered and incident photon share the same frequency. Means red was coming out, incoming was blue one was coming out. Okay, so this is your Rayleigh scattering. Okay, now one thing we should be aware of, I guess you are knowing this, but if you have forgot, let's see. You know what is atom? Atom is the smallest unit of matter or fundamental unit of matter. For example, I, this marker, this board, you, your laptop, everything is matter. Matter is having some space, right, around it. So this is all about matter. Any matter is made up of atom. Atoms are the smallest entity. For example, a house is made up of brick. In the same fashion, matter is made up of atom. So atom looks like this. There is neutron, proton and electron everywhere in the orbit. So these entities are known as orbit. and this thing is known as nucleus. So in nucleus, neutron and protons are there. In chemistry we will be doing it once again, don't worry. And in orbit there is electron everywhere, right? You need to understand one thing, that electrons have great affinity. This point you need to remember once for all. Great affinity towards light. In cosmic physics, everywhere I am going to use this concept, and you will also use it. Okay? Remember this concept. Electrons have great affinity towards light. Whenever they come in contact with light, they absorb the same and become excited. Okay? In excited state, they change their orbit. Their orbit by jumping into higher orbits. After some time, they come back to their original orbit and release the absorbed photon. Photon means light. Okay? I hope you were copying this. Don't expect that whatever I have written I will dictate. So suppose light was coming on this electron. So this electron will become excited and it change its orbit. Okay? First understand, I will give you some time. So when light was coming, so it absorbed, it became excited, it changed its orbit. Whatever is written, I am just making you understand. So it changed its orbit. Here there is one more electron. He said, Dost, my privacy is getting compromised. Please go back to your home. Okay? This guy was hurt. He came back to original orbit and released the absorbed photon. So whatever he had absorbed, he had released. There can be second scenario also. It again jumped to the next orbit. Second scenario, after absorbing some light. But when he said, please go back, my privacy is getting compromised. So he can go to another orbit also. Okay. So here another light ray will be reflected. Not entire energy will be released because it has to come back to its original orbit. And in second go, it will come back to its original orbit. Okay. So here also it will release some of the light. Understanding this, electron can directly jump to its original orbit, or it can enter into first orbit then to second orbit. Okay. In simpler word, you went to your uncle's house, your uncle did not entertain you, you came back to your home because you lost faith on your relatives. Second option, you went to your uncle's house, your uncle did not entertain you, but again you went to your Masi's house just to check that every relative is of that type, or you can be trustful on some of them. Then she also told that after some day, go back to your house, you came back. Understanding this? So first case, you directly came back to your house. In second case, you just toured to different relatives' house. Okay? There was a tour. So please note this, then we will see Raman and Rayleigh scattering. Rayleigh scattering we'll see in different manner also. Just copy it. Okay, come back to PPT. Now see here, these are orbits on the PPT, the blue one and the dotted one, these are orbits. And I have not made it circular because diagram will be bit complex. So to make it simpler, straight lines are made. Consider them as orbit, the circular one, right? Suppose there is one electron, a light, red light comes, so this is absorbing that light and it is going to change its orbit because it has become excited. Are you getting this? So here it will be told that privacy is compromised, please come back to its original orbit. So it will come back to its original orbit and it will release the photon. You clearly saw red photon was absorbed and red photon is released, so that is why this is relay scattering. This is relay scattering. Take another example. Same. Again electron was hit by red photon, it absorbed the red photon, it became excited, it changed its orbit and it again tried to come back. But instead of coming back to its original orbit, it went to another orbit. That is why it released different spectrum, different color of light. This is your Raman scatter. Okay, this is your Raman scatter. I will make you understand, don't worry. Just see this. Suppose violet light is coming. So violet light is getting out. This is your relay scattering. Violet light is coming, some other color is coming out. For example, the green one. This is Raman scattering. 99.9% follow relay scattering. Only 0.01% follow Raman scattering. Raman was able to deduce this. That is why he was awarded Nobel Prize. Okay. If you have not understood, one more example for you, and even after this there is some difficulty, rewatch, you will be able to understand. Last attempt from my side, because we have to see other topics also. Suppose this is your house. This is your friend's house. And this is suppose restaurant cum bar. You are in class 10th. Go back to the days, golden days, right? You were class 10th. Your father gave you 1,000 rupees. Your father gave you 1,000 rupees and asked you, go for party. You said, wow. So you just went to the restaurant with your friend. You ordered food for rupees 900. Okay. And came back to your house, spending Ola or Uber, spending on Ola Uber rupees 100. So your father gave you 1,000 rupees. You spent 900 plus 100, that is 1,000 rupees. So this is your relay scattering. The incoming is equal to outgoing. Now suppose this is the time, current time. Your father gave you 1,000 rupees, right? Again you went to the restaurant cum bar, but here you spent 900 rupees on somras. Somras means alcohol. You rather boozed instead of having dinner. Then you remembered, oh my God, father is at home. He will be asking some tough questions, right? And definitely different sort of treatment will be given by him. You came to know. Then you realized this is not the right time to go back home. If I will go back home, you know what will happen. So you called your friend and you took your friend on loudspeaker. Okay, you were with your friend. Okay, you called your father rather. The phone was on loudspeaker. You said that, father, I am going for study. Today at Vision IS the faculty was not up to the mark. I have not understood some concept. I need to visit my friend's house for night study. I will come tomorrow morning. Your father convinced. He was having tears in his eyes that even after having party, he is thinking of study. He will definitely become IS officer, right? So what you did, instead of going back to your house, you went to your friend's house. And in this course, on Ola Uber, you spent rupees 70 because you have to go back to your house also, no? You will keep some money, and definitely money will vary as per the distance on Ola Uber. So you spent 970 rupees. So you got 1000 rupees, you spent 970 rupees, this is your Raman scattering. Okay. So if incoming photon and outgoing photon have same color or same frequency, that is Rayleigh scattering, else it is Raman scattering. So give heading Rayleigh scattering. Right. It involves the interaction of electromagnetic waves with the particles whose size is smaller when compared to the wavelength of electromagnetic waves. Right, further, it is elastic scattering. It is an elastic scattering. It is an elastic scattering where the incident and scattered photon share the same frequency. The incident and scattered photon share the same frequency. Next point you write, the sky appears blue because of Rayleigh scattering. Next you write Raman scattering. Right. It is a scattering at atomic or molecular level. It happens due to excited electrons. Right. It is an inelastic scattering. Why? Because scattered and incident photon will not have same frequency, just the opposite of elastic. It is an inelastic scattering. Next you write, it helps in understanding the structure of atom. It helps us in understanding the structure of atom, proving the truthfulness of artifacts proving the truthfulness of artifacts, etc. Proving the truthfulness of artifacts, etc. Next to write. For this experiment, C.V. Raman was awarded Nobel Prize. For this experiment, C.V. Raman was awarded Nobel Prize. Okay? Try this question. You have just a minute to answer this. Okay, I am reading if response is there. Very easy question. While Raman scattering is all about elastic scattering of light, Rayleigh scattering is all about inelastic scattering of light. Right? Read the second one. While Raman scattering leads to change frequency, Rayleigh scattering leads to unchanged frequency. Gentlemen and women both, the first statement is just the opposite, right? Raman scattering is inelastic because it leads to change frequency. So option 2 is right and option 1 is not right. So correct answer is option B. Let's move to the other topic, total internal reflection. So before dealing with total internal reflection, let me give you some concepts. Keep these concepts in your head. And I would request do it parallelly with me. Okay. Suppose you are able to see this object. Okay. Why you are able to see this object? You are able to see this object because light is getting reflected from this object. And second point, it is reaching your eye. So two criteria are important for you to see or visualize any object, right? The first criteria is that light should be reflected by that object. Second criteria, that light should be reaching your eye. You may also say that eye should also be in proper position, proper condition. We are not considering those criteria. Biological factor, not only the factors of physics. Understanding this? Earlier Greeks were the scientists, so their idea was from human eye, light is coming. That is why we are able to see the object. This understanding went for many years until a Middle-aged scholar discovered that no, light is getting deflected by the object. He questioned that if light is coming from the eye, why we are unable to see objects at night? It should be coming from the eye at night also. Then it was observed, no, in dark we are unable to see because light is not getting reflected by that object, right? So the first criteria, you want to see this object, the light should be reflected from this. For example, you are able to see this marker? Yes. I am keeping this marker here. Are you able to see this? No. Why? The light is getting reflected from the marker, but it is not reaching your eye. Now do this. Keep your pen in your hand. Okay, I have got some answer from Antushosh and Niharika, but it was late. Very sorry, I could not take your name. Now do it parallelly with me. Suppose, keep it like this and observe. You will be able to see the pen very clearly, and you will be able to see what? The brand of the pen, right? मेरे भी focus कर दो थोड़ा, है? ठीक है, brand of the pen. Now do this one thing. Keep the pen this way, right? Keep pen this way and look in a straight way, in a straight line. You will have a blur image of the pen, right? You will have the blur image of the pen, but you won't be able to read whatever is written on the pen. You won't be able to recognize the brand, etc. There will be blur image, right? Do pen here, keep pen here. Again watch. What will happen? Again a blur image will be formed. Put pen here, correct image is formed. Means what? If light is getting reflected, it should reach you. Means you should see in the direction of reflected light to observe it very clearly. For example, here it was getting reflected, I am looking this side. So a blur image is seen, but not a clear image. To see the clear image, I will have to see in the direction from which light is coming. If you want to see moon, you will have to see upward, right? Moon will not come downward to make the presence. Is it fine? So you understood the idea? Now focus on PPT. So this is called line of sight. From where the light is coming, you need to look in that direction. That is called line of sight. Now see the PPT. Total internal reflection. What is happening? For total internal reflection to occur, the first criteria is that light should be in denser medium. Okay? PPT पे है? Light should be in denser medium. So suppose this is water. So I am keeping the object, illuminating object or luminous object in the water itself. So what will happen? Light is coming. So light is coming. A normal is drawn, 90 degree. Changing the medium, refraction, coming back to the medium, reflection. I am slightly slanting the incident light. Again, normal, reflection, refraction. The red one will be refraction because it is changing the medium. The most simple explanation we were having. Again, reflection, refraction. Again, reflection, refraction. Try to appreciate this. As I am inclining or slanting my incident light, as I am inclining or slanting my incident light, similarly my refracted ray is also getting inclined. Similarly, my refracted ray is also getting inclined, and a time comes that for a particular angle of incidence, this one, particular angle of incidence, the refracted ray coincides with medium interface. Right? A time comes when the refracted ray coincides with medium interface. If I further slant my incident light by 1 degree also, okay, by 1 degree also, this will not be able to leave this medium. It will be remaining in this medium. And if it is not changing the medium, it is called what? Reflection. That is why total internal reflection. The refracted ray will not be able to leave the medium after that particular angle. And that particular angle is known as critical angle. PPT. That particular angle is known as critical angle, that angle of incidence at which it was on the surface itself. It is known as critical angle, right? So after this, if I am slanting my incident light, it will remain in the medium, it is not going to change the medium. This is your total internal reflection. So just write 2 lines about TIR, total internal reflection. In short, we will be writing it TIR. First point you write, light should travel from denser to rarer medium. Light should travel from denser to rarer medium. Second point you write, angle of incidence should be greater than critical angle. Second point you write, angle of incidence should be greater than critical angle. Should be greater than critical angle. So on total internal reflection, we are having some very important thing. For example, optical fiber. Optical fiber is like this. There is a coating on optical fiber. So this is called coating on optical fiber. Okay. So this is called core and this is called clad. These are made up of dielectric medium. Do not take dielectric medium. Understand they are made up of what? They are made up of glass and plastic. That will suffice. So in optical fiber, density of core is greater than density of clad. This is how we construct optical fiber. And the purpose is Niharika is asking, sir, when light passes from air to glass, only wavelength is affected. Yes, wavelength and speed. Frequency remains unchanged. Now, what is the purpose of having optical fiber? These are used for communication purpose. How they are effective in communication, let's understand. Okay. For example, to make 5G a reality, India should be well connected with optical fiber, because optical fiber gives you faster internet and there is no loss of data. So for total internal reflection to happen, two criteria are important. First criteria is object should travel from denser to rarer. So this is optical fiber, so this is your core and this is your clad. So you know one thing, that density of core is greater than density of clad. Are you able to appreciate this? That is what I written. And light is traveling in core itself. So light is incoming from core, means denser to rarer. And second thing is angle of incidence is greater than critical angle. Critical angle is some special angle. Since it is made up of glass, so critical angle for glass is around 42 degrees. So what is happening here? We are making light incident at 45 degree. So 45 degree is greater than 42 degree or not? Yes. So second criteria is also getting fulfilled. Angle of incidence is 45 degree and critical angle is 42 degree. So this criteria is also fulfilled. Right. So now see how optical fiber is working. Suppose 100 message means 100% is sent. It will come 45 degree, it will be reflected. There will be no refraction. Why no refraction? Because here TIR will happen, total internal reflection, because it is fulfilling both the criteria. Light is incoming from denser medium. It is incoming from denser medium. Core is denser and it is rarer. And second is angle of incidence is greater than critical angle. Light will be coming at this surface also. Again from denser medium, it will go back. So 100 will be traveling here. No message loss. 100 will be coming here. No refraction and 100 will be coming out. So incoming was 100 and message received is also 100. Right. So message sent and message received both are equal. Alright? Just pen it. I am now going to tell you that if optical fiber is not used, then what can be the problem? Now the same thing, okay, if optical fiber is not used, then see what can be the problem. Okay, no core, no clad type of thing, because if it is not optical fiber, definitely no core and no clad. No critical angle thing, nothing. Suppose 100 is coming, so what will happen? Refraction will also happen. So 100 is coming from here. Suppose 1 is lost in refraction, so 99 will be forwarded. Here also refraction will happen. Suppose 1 is lost, 1%, 98% is forwarded. Again 1% is lost, 97% is forwarded. Here also 1% is lost, 96% is forwarded. Are you able to appreciate this? 100% message was sent, but 96% was received. Do you believe that this sort of system is going to give you speed or accuracy in message sending? No. Communication will be affected. But in optical fiber, there is no hindrance. There is no message loss because refraction at any surface is not observed. So that is why optical fiber is better way of communication. Okay? So this you can anytime make. This is just for your understanding. I have made this. That much message is not lost, but yes, messages are lost. So see the PPT. This is how your optical fiber works. Okay, there is no loss. Are you able to see everything is traveling in the code itself? Now we are going to start important topic, optical illusion. We will start from Mirage. Okay. There is animation. You are expected to see the animation and only the important points will be dictated. Okay. So be ready with me to write the important points. First, Mirage. So Mirage is what? It is an optical illusion which happens hot summer day or any hot day. Here inverted image of the tree is observed. Though the tree is not inverted, but you will find the tree to be inverted. So how mirage happens, let's understand. Suppose this is a tree and this is a hot summer day, so definitely there will be multiple air pockets or not. There will be multiple air pocket. If geography is over, you will be able to understand what is air pocket. Air pocket means within that range, air density is constant. After that, air density is bound to change. So in summer days, if I am moving from downward to upward direction, bottom to up, density is bound to increase. And suppose this is you. Why density will be increased? Because this is the surface, right? So this is the surface, it is hot day, so air will be rising up and air will be accumulating at this point. So accumulation of air means higher density, right? So I can clearly say if I am moving from downward to upward, density will increase. Suppose this is 5, 10, 15, 20. Air pocket means within this range, density is 5. Within this range, density is suppose 10. Here 15, beyond 20. Just for your understanding, for the sake of understanding, I have given the number. Now you wanted to see the tree. You are there with your all equipments, right? So you wanted to see the tree. So light should come from tree itself. So light should come from tree itself. Now tell me, it is coming from rarer medium to denser or denser medium to rarer? It is coming from 20 to 15. Just see this, that air pocket is having 20 as density, the lower air pocket is having 15, means denser to rarer. Speed is bound to increase, and if speed increases, it moves away from normal, again away from normal, because it is coming from denser to rarer medium. At this point you are bound to believe that total internal reflection is happening. This you will have to suppose. If you will not go with this, no mirage will be formed. I guess that the average age of the class is 23-24 years. Believing that, I believe that none of you have seen mirage 20 times in your entire lifetime. Why is it so? Because mirage are rarest of rare phenomena. These happen if some events are triggered in the same fashion that they are expected to be. Means here, if total internal reflection does not happen, mirage will not be formed. Those who are having physics background, they may be thinking that I am teaching you wrong. Definitely I am teaching you wrong. But for our UPSC requirement, we are going for general science, right? So in general science, we will have to go with this understanding only, that refraction and total internal reflection are happening. Though it is a parabola, that it is a parabolic path due to refraction, and it can be proved by Snell's law, that I know. Okay, so please do not counter me on this. For UPSC requirement, whatever I am telling you is right. So here you will have to believe total internal reflection is happening. So TIR is happening. Now see, now it is going from rarer to denser. So speed is bound to decline, and if that is the case, it will move towards normal. Just see the refraction that I have made you written. Again towards the normal. Now he will use line of sight. Light is coming from downward direction, so he should look downward. So he looks downward. That is your line of sight. You wanted to see the pen, so you needed to see the pen in that direction. You wanted to see the moon upward. So this is line of sight. Hence tree appears to be inverted. This is your mirage. Okay. Right. Give heading mirage. It is an optical illusion. It is an optical illusion taking place at hot places. At hot places. Next, object appears to be inverted. Object appears to be inverted. Next, refraction and TIR, total internal reflection, refraction and TIR, total internal reflection, are the responsible phenomenon. Are the responsible phenomenon. Okay, are the responsible phenomenon. There is contrasting brother of mirage, that is looming. Okay, the diagram on the PPT is wrong, not wrong entirely but slightly wrong. Looming is just opposite of mirage. It will happen in colder places or colder climates. Colder climates or colder places like ocean, right? Like ocean. So if I consider ocean, here density will increase in downward direction or not. Why? Because if it is cooler place, air is going to sit, so density will be more at the bottom. Suppose there are again multiple air pockets. Okay, multiple air pockets. Let me name it 5, 10, 15, 20, 25 and 30. So you can clearly say this is how density will go. Highest density will be at the bottom, opposite of mirage. You wanted to see this? So light should come from here. It is coming from denser to rarer, away from the normal. Away from the normal. Here I am considering total internal reflection. Towards the normal. Towards the normal. Towards the normal. Okay. Now line of sight will be used. The boat will be appearing here. So here boat will be object appears to be suspended in air. This is the quality of looming. Okay. Object appears to be suspended in air. Erect object is observed. You cannot see that the boat is inverted. So erect object is seen. Happens at colder region. This is again optical illusion. And refraction plus TIR are again responsible phenomenon. Write this. This is what is important in case of looming. Okay. So I hope you have written. So let's move to the next topic, that is rainbow. So if you will observe rainbow, then white light is coming. It is breaking into 7 individual colors. So this phenomenon is known as dispersion. So actually rainbow is appearing or behaving like a prism. So in prism you have seen that white light splits into 7 individual colors. So during raindrops are suspended in air. So because of that they split into 7 individual colors. That is the phenomenon of dispersion. Here they will be again returning in the medium, that is your TIR, total internal reflection. No, nothing is going out, everything remains in the medium. And here what is happening? Refraction. So make this diagram as it is. You can clearly see 3 phenomena are responsible for this. So please copy that. PPT पे PPT पे Okay, I hope that is it. Now just see on the board, I have made two rainbows. If the outer circle is red, it is primary rainbow, and inner circle is violet. The other thing can also be possible, that outer circle is violet and inner circle is red, that is secondary rainbow. So please write this. We may find a secondary rainbow in nature. We may find a secondary rainbow in nature where the outer circle is violet, and the inner circle is red. Outer circle is violet and inner circle is red. This may happen if more than two total internal reflections are involved. If more than two total internal reflections are involved. If more than two total internal reflections are involved. Okay, like what can happen? Instead it going out, it again reflected here. Okay, then it is coming here. So don't you think the red will be inverted? So this is what I wanted to say, that this TIR should be repeated, not other thing. But having these three together is rare. Happening two TIRs will further be rarer. Are you getting this? So next point you write, it is more rare than primary rainbow, or it is rarer than primary rainbow. It is rarer than primary rainbow. It is rarer than primary rainbow. Continuing with optical illusion, twinkling of star. Twinkling of star is again a kind of optical illusion. Just see this. Suppose this is a star, so rays will be coming from star. On a tree, there were 5 to 10 air pockets. Okay, but if star and earth is considered, definitely the distance is too much, hence millions of air pockets will be there, thousands and millions of air pockets, right? So don't you think light will be bending or refracted a lot too much, right? It will be refracted a lot number of times. Because of that what happens? Too much refraction is observed. So suppose it is you, it is human eye, and suppose this is star. So light from the star will be reaching to human eye after multiple refractions. There are multiple air pockets, so multiple refractions. Don't you think that the atmospheric circulation on earth is very complex? This is RB1, I guess geography should be over. Okay, if it is not, sir will tell you that complex nature of atmospheric circulation. Every second the density of any air pocket can change, right? And every second light is reaching to your eye. So what happened? Next second, because of changing atmospheric circulation, it may reach at some other angle. Next time at other angle. Next time at other angle. Are you getting this? So light will be coming at some deviated angle, and hence human eye will be trying to find the exact position of the star by using line of sight. So line of sight will also be adjusting per second. Okay, it is also coming at slanted thing. So line of sight will also be slanted. So you will see star like this. Okay, trying to fix the position of the star. Hence it appears to be twinkling, repeating. Multiple air pockets are there, multiple time refraction. So after refraction it reached. But since the atmospheric circulations are complex, so each time refraction will be at different angle, because density of air in every air pocket will be changing, not every, few air pockets. Because of that, line of sight will be adjusting itself every second, which makes star appearing to be twinkling. Write this. Right. Multiple air pockets are present between star and surface of the earth. Star and surface of the earth. Right? Refraction is taking place through all these packets. Refraction is taking place through all these pockets. Refraction is taking place through all these pockets. Next, due to dynamic nature of atmospheric circulation, line of sight is adjusting every second. Line of sight is adjusting every second. Because of which we are unable to locate exact position of the star. Because of which we are unable to locate the exact position of the star. Hence we find stars to be twinkling. Hence we find stars to be twinkling. Okay. Now just see this. You will be able to see very easily what? Every time it is changing, that is why you are unable to fix the position of star. Next point you can write, far stars twinkle more than the nearer star, because longer path means more refraction. So that is why you write far stars twinkle more than the nearer star. Okay. Now I will not be dictating anything. Okay, whatever I will be doing, that will be on board. Why is the sky blue? Rayleigh scattering, everybody knows, right? Now I am going to counter something and focus on board. This will be probably the last topic of the day. We will continue with optical illusion in the next class. I am just copying visible spectrum, VIBGYOR. I told you in Rayleigh scattering, shorter wavelength scatter, that is why sky appears blue. Shorter wavelength like blue. So they scatter a lot, that is why sky appears to be blue. But nobody countered me that, sir, violet and indigo are having lesser wavelength than the blue one. Why not sky appears to be violet or indigo? Nobody countered on this, right? For this to understand, two explanations are available. Okay? PPT 1 kar. Two explanations are available. Okay? The first explanation is violet comprises only 1%. Violet comprises only 1% of the visible spectrum. That is why it is negligible. But the more apt explanation is I am going to give you. This is because of your eye. Human eye is responsible for this. So do it parallelly. Nothing will be dictated. So this is your human eye. This is called retina of the eye. Retina is nothing but screen of the eye where image is formed. Okay, so this is your human eye. Thank God that the earlier poets had not seen human eye in this form, else they would have not written तेरी आंखों की चाहत में सब कुछ भुला दूंगा, right? Nobody is going to have चाहत with this sort of eye, but this is what we are having. So retina is comprised of two things. It is made up of two things. One is your cons and other is your rod. R for rod, R for Rath. Okay, so rod is responsible for your dim light vision. So if you are able to see at night or in dark, this is all because of the rods. Okay. Cons are responsible for two things. First is your daylight vision. So if you are able to see in light, it is because of the cons. And C for con and C for color. So they are responsible for color recognition also. So they are responsible for color recognition also. So human eye recognizes only three colors: red, blue and green. Rest colors are determined based upon the intensity of these colors. Okay, the mixture of these colors are getting formed. So only these colors are recognized. That is why these colors are also known as primary colors. That is why these colors are also known as primary colors. To focus on the fact that violet, indigo, blue, everything is getting scattered. Consider that you are in a party where three flavors of ice cream are available: butterscotch, vanilla and chocolate. Your affinity is towards chocolate. You are going to have chocolate, right? So these three colors are scattered a lot, but human eye is having more sensitivity or affinity towards blue color. So that is why you find sky to be blue. So make a table. We will have some discussion on this. Particles suspended in atmosphere. Okay. Suppose the situation or circumstance is normal. The particles suspended in atmosphere are dust particles that we have seen in Rayleigh scattering. Okay, I am just explaining Rayleigh scattering once again, but in different way. Application I am explaining. So scattered spectrum is violet, indigo and blue. These are the most scattered one, but color of the sky is blue, as cones are sensitive, ऐसे कर लो, cones are sensitive to blue color. Situation is cyclonic or stormy. So particles suspending in atmosphere will be salt. Scattered spectrum will be violet and indigo will be scattered more, blue will be scattered less. So color of the sky will be violet plus indigo. Indigo means pinkish. And third is heavy storm. So heavy water droplets or big water droplets will be suspended in atmosphere. Violet is scattered this spectrum, so sky appears to be violet. The last two happen at higher latitudes, and that also in coastal areas. Why? If salt is to suspend in atmosphere, definitely it should be near marine area, because coastal area means how it will rise. Understanding this or not? Into atmosphere, that will be if it is at higher latitude. That is why in USA or Japan, if cyclonic conditions are there, initially the sky appears to be violet and indigo, and if storm gets intensified, then violet color appears. In normal circumstances, dust particles are there, that is why blue color is observed, else the color of the sky is bound to change because particles suspended in the atmosphere change. Okay, so this table you need to remember. Now we will do one thing, and after that we will leave one optical illusion because there are many questions to cover. Please do not see the answer of those questions. Okay, we will be doing in next class. One optical illusion I am deliberately leaving because we have to start with the questions. So I will be teaching one topic and then we will start questions next class. So now one more observation before leaving, that sometimes sky appears or the sun appears to be red during dusk and dawn, and sun appears to be colorless during noon. Why is it so? So again I am writing on board, you just copy. So suppose this is your earth, and suppose this is your sun. Okay, so this is suppose situation of noon. So at noon sun will be overhead, right? Sun will be overhead. And suppose it is dusk or dawn, morning or evening, sun will be at horizon, क्षितिज पे होगा, at horizon. Okay, sun will be at horizon. So if something is overhead, means 90 degree, sun rays reach earth at 90 degree, means shortest distance, perpendicular distance. So what happens here during noon? Apparent distance traveled by light is less. So at noon, apparent distance traveled by light is less. Because of this, if distance is less, scattering of every spectrum means vigor is negligible. Because of that, scattering is negligible means what? All colors will come together. So sun or nearby sky appears white. Sun or nearby sky appears white. So every color come together, so there is nothing. But if sun is at horizon, means dusk or dawn, so here apparent distance will be so much, okay? Because it is come at slanted. So slanted means curved. Curved light will be traveling more distance. So apparent distance traveled by light. That is why I have made this one bigger. By light is more. If it is more, so we can say that scattering of shorter wavelength like blue is a lot. Because of this, human eyes lose sensitivity to blue color. Okay, only higher wavelengths like red, orange, etc. are able to be recognized by eye as they scatter less. Hence, sun or nearby sky appears red, okay, or sometimes orange also. So have you seen that at morning and evening, sunrise, sunset, sun appears to be red. Why it appears to be red? Because distance traveled is so much, so blue loses its sensitivity, right? If suppose I told you 1 liter of water was spread on the table, you saw that water everywhere. But if the water is spread on the entire floor, you won't be able to recognize, because it is a very large area and water volume was not that much. So understanding this, so distance increases, so that scattering is unable to be sensitized by human eyes. So this is the idea. Okay. Have you heard a song from Kite movie? Zindagi do pal ki intezar kab tak karenge bhala? Tumhe pyar kab tak karenge bhala? Have you heard? Right. So that song is saying what? That he needs to change the crush because the crush has scattered a lot. बहुत भाव खा लिया. So in the same fashion, the blue has scattered a lot beyond the limitation that human eye could recognize. So आपको भाव उतना ही खाना चाहिए जितना सामने वाला दे सके. So this is the same thing. Okay. So this is where we will stop today. Next class we will continue with ray optics, lenses. Okay. Electric and magnetic effects of current, etc. Okay. Thank you.